Good evening, algebra students. I hope that everybody is doing well. We are continuing in chapter 9, and this chapter is all about parabolas and quadratic equations. So we're now in section 9-2, day 1. We're going to focus on the axis of symmetry in the vertex today. What I'd like for you to be able to do by the end of this lesson is to identify and calculate the axis of symmetry in a quadratic function. So, recall what that is. The axis of symmetry is the vertical line through the vertex of a parabola. It divides the parabola into two matching halves. That's important. It divides the parabola into two matching halves. So for an example, if we have a parabola like this, the axis of symmetry would be going right down the middle of it like that. Now, we can easily see what the axis of symmetry is if we have a graph of that function. But what happens if you don't have a graph? What then? Well, if you don't have a graph, we have a formula we can use to calculate that. The formula that we are going to use is right here. X is equal to negative b over 2a. So this is going to tell us where the axis of symmetry is. If you don't have a graph, and need to find the axis of symmetry, you're going to use that formula right here. Now that might seem a little strange. What is B? What is A? Well, all of our equations that we have are going to be in the form y equals ax squared plus bx plus c. So we are going to be able to look at what is in the A position and put that in the A spot. We're going to be able to look at what is in the B position and put that in the B spot. So let's just do that real fast. Let's look at a couple of these here. So let's look at this equation. The A is negative 2. Notice the negative 2 is in front of the x squared, just like A is in front of the x squared. The B is negative 3 because the negative 3 is in front of the x, just like the B is in front of the x. The 12 is the plane number, or C, just like C is all on its own. Over here, 7 is the C, 4 is the B, and there's an invisible 1 for the A. In this one right here, there's an invisible 1 for the A, a positive 6 for the B, and a negative 9 for the C. So we've got ax squared plus bx plus c, ax squared plus bx plus c, ax squared plus bx plus c. What we're going to do is use those values that we're going to pull out of our equations and substitute them into our vertex formula. So I'm going to write my vertex formula out just kind of in the middle. X is equal to negative b over 2a. And let's start doing that. We are, not vertex, axis of symmetry. It says find the axis of symmetry for the following quadratic functions, and that's what we're going to do by plugging our values into this equation or formula right here. So we want x equals, and then negative b. Well, what is the b in this equation? The b is the 4, so I got the 4. Over, and then there's a 2, and then I need to substitute something in for the a. Well, what's the value in front of x squared? It is the invisible 1, so I'm going to put a 1 right here. Now this reduces to negative 4 over 2, or negative 2. So my final answer is x equals negative 2, and that's my axis of symmetry. Let's do it again. X is equal to negative b over a. The b value, well, I need to put my negative in. The b value is the 6. So I'm going to take that 6 and put it in the b spot. Then the bottom of my formula is 2 times a. Well, what is in the a position? A is 1. That's an invisible 1. So this is going to reduce to negative 6 over 2, or negative 3. So now my final answer is just x equals negative 3. This is the axis of symmetry. for this equation right here. This is not the axis of symmetry for some other random equation. It might just so happen to be a happy coincidence for some other equation, but not for these others. This is the axis of symmetry for this example and this example alone. All right, let's do example C. We're going to do negative b over 2a. So I have x equals negative. The b value here is negative 8. So I need to put negative 8 in that spot. Over 2 times a. A is once again an invisible 1. But the negative of a negative is a positive. So that means I now have positive 8 over 2, which reduces to 4. So now I have x is equal to positive 4, and there's my axis of symmetry. So this is the first step into being able to graph a quadratic equation and also just learn some things about it. So we are going to do example D and E in class. So for now, please flip your pages over and we're going to do the back part. So we've just talked about how to find the axis of symmetry. And remember, the axis of symmetry is that line cutting a parabola in half. How do you find the vertex, though? Well, let's talk about what a vertex is real fast. A vertex is always on the axis of symmetry. So here's the axis of symmetry. The vertex would be this point right here. That's the vertex. So what we can do is use the axis of symmetry to help point us to where the vertex should be. So our step 1 is going to be to find the axis of symmetry. So we're going to use the equation for the axis of symmetry. Then you're going to substitute that value in and then write it as an ordered pair. You're going to see what I mean by that when we do a couple of these examples. So it says find the vertex of the quadratic function using the axis of symmetry. Step 1 is to use what we just did on the opposite page or on the opposite side of this page by saying x is equal to negative b over 2a. We're going to have to do that first on all of these. So let's do that. X is equal to negative, and then what is in the b position? The 8 is in the b position. So I'm going to say 8 over 2 times a. Well, this 2 is in that a position. Well, that reduces to negative 8 over 4 or negative 2. So right now, I have x is equal to negative 2. This is the axis of symmetry, but now I'm going to use this value and stick it back into the function to figure out what y would need to equal. Because remember up here, we had our axis of symmetry, but the vertex always has to be on it. So if we can find the axis of symmetry, then we can use that to kind of point us in the direction of the vertex. So I'm going to take this x equals negative 2, and I'm going to replace the x up here. So this is becoming y is equal to 2 times negative 2 squared plus 8 times negative 2 plus 3. Now we need to follow order of operations. So this is going to be y is equal to 2 times 4 plus 8 times negative 2 plus 3. Now you might be thinking, how did you get 4? Well, this is negative 2 squared. Negative 2 times negative 2 is positive 4 because a negative times a negative is a positive. So now let's do multiplication. So now I have y is equal to 8 minus 16 plus 3. And I have y is equal to, I believe that is going to get me negative 5. So at this point, I have an x equals a number and a y equals a number. But how do I get it to where it looks like a vertex value? Well, I'm going to put them together and make a coordinate. So I am going to say negative 2, comma, negative 5. All right, I was worried that I made a mistake, but I think I did okay. On the next one, we're going to do the same thing. The first thing you do is find the axis of symmetry, which is your negative b over 2a. So x is equal to negative, and then I'm putting my 6 in for my b, and then 2 times negative 1, which is negative 6 over negative 2, or 3. So now I know x is equal to 3. Wonderful. This is the axis of symmetry. But where on that axis of symmetry is the vertex? So I'm going to take that x equals 3 and substitute it back in. So this gets me y is equal to negative of 3 squared plus 6 times 3 minus 2. Now I'm following order of operations. 3 squared is 9, so I have y is equal to negative 9 plus 6 times 3 is 18 minus 2. So negative 9 plus 18 is positive 9, and then positive 9 minus 2 is 7. So I have y is equal to 7 right here. Here's my x equals 3, here's my y equals 7. I'm going to put them together to form my coordinate, and that's getting me 3, 7 for my vertex. We're going to do that one more time. So in this equation, I'm trying to find the vertex. I don't have a graph, so I can't easily look at it and say, oh, there's the vertex. So I need to have a strategic way to calculate it in a way that's going to consistently get me the right answer. So this is how we do it. We first find the axis of symmetry, and then we substitute that value back into the equation. So let's do that. We're first going to find our axis of symmetry by using negative b over 2a. X is equal to the negative of negative 3, because this negative 3 is the b, over 2 times a, which is 3. Well, the negative of negative 3 is positive 3, and 2 times 3 is 6, so this reduces to 1/2. Right now, I have x is equal to 1/2. Don't let a fraction scare you. Just stick it into your equation. You'll be okay. You might want to change 1/2 to 0.5 temporarily, just so you can easily put stuff into your calculator, but you don't have to. I'm going to temporarily change this 1/2 to 0.5 so I can easily type stuff into the calculator for you. So this is now, I have my x value. I'm trying to figure out my y value, so I'm going to substitute it in. Y is equal to 3 times 0.5 squared minus 3 times 0.5 plus 1. Well, if we use our calculator and we take 0.5 times 0.5, we should be getting 0.25. So now I have y is equal to 3 times 0.25 minus 3 times 0.5 plus 1. I did my exponents first. Now I'm going to do multiplication. So 3 times 0.25 is 0.75. So y is equal to 0.75 minus 3 times 0.5, which is 1.5, plus 1. Now just add that up. So I'm going to take 0.75 minus 1.5 plus 1, and that's going to get me 0.25. Or 1/4. So now I know that y is equal to 1/4, x is equal to 1/2. It's okay that I have fractions. My answer is 1/2, 1/4. And that is my vertex. So there we have it. We will be doing more of these in class and practicing with it so you can get used to it a little more, because this is a new way to think about stuff. But we are going to save D and E to do those in class. So that's all we have for this note video. I hope you have a good night.